it's my great pleasure to welcome Wendy back. She was a speaker last year at Blockchain Technology Symposium 21, and so back by popular demand. And she's been involved in clinical trials. So we're turning from our discussions of future networks now to another use case or application area where privacy, confidentiality, and the properties of blockchains are really important and offer us much potential. So Wendy's been involved in clinical trials from every perspective for 30 years with a strong background in operations and regulatory compliance. She currently serves as Chief Scientific Officer for Burst IQ, a healthcare information technology company specializing in blockchain and AI. She's also a lecturer, faculty member in the health administration program at the University of Colorado in Denver. And Dr. Charles augments her blockchain healthcare experience by serving on the EU Blockchain Observatory and the Forum Expert Panel. She's also HIMSS with his health information management. I'm not sure what the two S's, maybe you can help us out there.
Yeah, System Society.
System yes. Society, thank you. Blockchain Task Force and Government Blockchain Association's Healthcare Group, as well as the IEEE Blockchain Working Groups. She's also involved as an assistant editor and reviewer for a number of academic journals. She's obtained her PhD in clinical science with a specialty in health information technology from the University of Colorado on Schutz Medical Campus, and she's certified as an IRB professional, clinical research professional, and a blockchain professional. So triple threat there, Wendy.
Yes.
So wonderful. Thank you so much for joining us today, and over to you.
Thank you so much for inviting me. I am delighted to be here. I love it that there's such an emphasis too on including students as attendees. And I hope that that the students who are in the audience today will be active in the discussion and asking questions. So starting out, I'm going to talk about these are the topics I'm going to cover. I'm going to first cover some highlights of health blockchains, especially after the last panel. It's just kind of to orient our thinking for how health blockchains might be different than what you're accustomed to. I'll cover some basics of dynamic consent and some blockchain-based dynamic consent considerations, as well as overall considerations about what would be responsible implementation for you considering going forward. Now, my goal is to speak to the blockchain community, health community, researchers, and the students attending today. And this is a non-technical presentation, so if you have questions, please spare me because I may not be able to answer some of the technical questions. So I'm also starting with a disclaimer. These views are mine, not necessarily for the BTS organizers or for Burst IQ. I do work for a company that has been producing blockchain services for healthcare and life sciences for 5 years. And I will talk about some of my work, but the goal is not to be promotional. It's just to give examples to explain concepts of what's being done today. And in my slides, I'll show images of individuals. Some of them were just obtained from Google. They are not intended to represent any known individuals or roles or health status. So starting out with some context of health blockchains, there's been so much great discussion about interest of blockchain in various industries. So I thought it'd be helpful to share about some background for blockchain in healthcare. So as of within the last couple of years, 40% of healthcare executives see blockchain among their top 5 priorities. Also, global healthcare market spend on blockchain is expected to hit a little under 6 billion in just the next few years, 2025. And it's believed that adoption of blockchain technology could save the healthcare industry up to 100 to 150 billion per year by 2025. In a variety of areas. And there has actually been some really promising ROI data thus far to show efficiencies in blockchain. So to orient us for the blockchain types used for health information, so much of the, I would say, general community focuses on the earlier blockchains that were developed, the Bitcoin and Ethereum blockchains. And there have been advances in a number of both public and permission chains. But it's important to orient ourselves today that the vast majority of health information is stored on a private and permissioned blockchain. Now, again, there's been some very promising advances with other types of blockchains, but it's important to orient ourselves to this sector. Now, this mindset is also important because I serve as an advisor to a few different governments, and I have the opportunity to see the absolute explosion of private and permission blockchains being used for healthcare. Now, why you might not see it is because many healthcare organizations or health-oriented organizations do not market that they use blockchain. And it's only used as a part of the architecture stack anyway, and they didn't want to raise concerns about the uses of technology. So they just don't tell anybody that they're using it. But I am so active in this industry. I am so involved in the development at a national level that you just got to take my word for it. This is just absolute explosion. So going back to some of the discussions that were had earlier about governance and permissioning, I thought it'd be helpful just to acknowledge that many people in the blockchain community question as to whether a consortium or a private blockchain would really be even a blockchain and whether these are truly decentralized. You know, I serve on an IEEE committee that is creating standards for blockchain governance across all industries. And we have had the most intense debates about the definition of blockchain. And for those of you in the blockchain community, you're probably familiar with a joke that if you ask 10 different blockchain experts for a definition of blockchain, you will receive 11 different responses. So what we did with IEEE, I think is a wise approach in general, is to look at what the market is doing and what are we seeing for evolution of technologies in the market being advertised. And when our committee saw that there were thousands and thousands of private or consortium blockchains that were marketing themselves as blockchain instead of DLTs, we decided to be maximally inclusive. And so that's what I'm going to do, in this presentation too, is to put DLTs and blockchains under the same umbrella and just call them blockchains for convenience. For those of you who are concerned about incentives and how do we keep people honest, we use contracts and we use very, very active governance mechanisms. In fact, there's a whole new branch of law devoted to blockchain governance in order to keep all parties honest. You may or may not agree with that, but it's interesting to see that this is what's currently happening and the strategies that these organizations are using. So to describe health blockchain maturity, I created this fictional graph. So it has fictional data, but I wanted to illustrate a point. So many people talk about blockchain in healthcare as being in its infancy. And maybe on average, we could say that that's in infancy, but there have been a number of very successful and mature blockchain instances that use actual healthcare. Just an example, the company that I work for has been in full commercial enterprise production for 5 years, and we store all health data on chain. Our technology has been used underneath 600 hospitals and has gone so many audits. And even though data are on chain, with over 12 million records on chain, it's all been deemed compliant and it's gone through security audits. So it's definitely doable. Some people say, well, a government would never agree with blockchain and healthcare, and you could never store data on chain or never use it for a wide scale purpose. So for that, I'd like to give you the example that in the United States, the Department of Health and Human Services has been managing all COVID reported cases from hospitals and healthcare agencies with a blockchain since 2020. And it has proven to be very efficient and effective at tracking those cases effectively. So for 320 million people, their data are stored with the blockchain, or at least the COVID cases are. And so there can be government acceptance as well. Next, when we talk about blockchain, many people focus on the audit trail. And for health blockchains, we have just moved so far beyond an audit trail to capabilities of a data engine with many advanced efficiencies. So it's been exciting to see that there's been some true ROI about the value delivered in blockchain and healthcare. And one of the next movements is that using blockchain-based knowledge graphs is all the rage right now with health blockchains. It's discussed on every international committee that I'm on, and that the goal is that it manages data in a way that we can create much more effective and intelligent insights. And I'm also pleased to see that there have been more advances for privacy and security for health information for enterprise cases. So these are just a couple uses of health blockchains, starting from how blockchains are currently being used in healthcare for health information exchanges. And it goes all the way down the spectrum to true patient engagement. And that's what I'll be focusing on today with dynamic consent. So for dynamic consent, what is it? So as one definition of dynamic consent, we could consider that it is a personalized digital interface that enables two-way communication between individuals and their data custodians. And I also like to include researchers in that mix to give those individuals greater understanding and control over how their health data are used. And this is a different approach to informed consent, with the goal of creating more engagement of those individuals and create better opportunities for linkage, because we can get permission to obtain other data sets, and also to seek permission when a reconsent is required, or when an organization deems it ethical to ask permission again for maybe a use that they hadn't originally considered. So why is this so important? Well, I hear a lot of misconceptions about informed consent, and this is where I wear my institutional review board or review ethics board hat. After having served as a review professional for so many years, informed consent is not a document, it's a voluntary agreement. And it's meant to be an evolving process, never a one-time agreement, and we would never expect somebody's agreement to last forever. And also, consent shouldn't be all or nothing, not when we have the technology to offer people more choices. And when we think about why this is so important too, we recognize that individuals change their minds over time, that they gain more information over time, especially after they hear news reports in the media, or they hear about a new and emerging technology. And we think about healthcare and life sciences as being rapidly evolving, and how the uses of data and specimens are going to be developed that we couldn't have anticipated at the time of consent. And how many of you, for example, could have considered how specific the DNA testing can be today, and how individuals are really not considered de-identified with DNA testing anymore. So where is it used in healthcare? It's used in lots of different ways, but for this presentation, I'm going to focus on 3 areas. So there's health websites and apps that are largely targeted to consumers. And then there's health data sharing from within healthcare organizations, and especially when it comes to sharing data for research. And the next part is informed consent for health research. And my big focus on this, where I work on this today, is using dynamic consent for data and specimen repositories, where individuals may agree that their data and specimens can be used for future research. And how do we give them more visibility and control over how their information and specimens are used? So I'm going to start out by giving you some examples of what dynamic consent can look like. So first, when there is an established relationship with an organization, there can be a preference page or a settings page where an individual can go within that website or in that app and review all of the ways that their information is currently being used and change their preferences. The next example is from a website. Now, everyone's familiar with cookies, and these are typical types of screens that you see when you go onto a website and they talk about privacy. So typically we are presented with this screen at the left that just says accept all cookies or customize preferences. And when we click on customize preferences, we're offered dynamic consent about how our information can be used for these different preferences. As the next example, there's agreement to services. And so this is an example from Twitter that shows the agreements that people would enter into when first creating an account. And this example at the left is about before we had privacy laws, people were asked to just blindly agree by and the wording states, by signing up, you agree to our terms, privacy policy, and cookie use. Well, how many people have read that? And it's an all or nothing agreement. And after new privacy laws have been implemented, there are now detailed privacy explanations, and you can see how many options there are for dynamic consent. And these can be changed at any time. This is an example from an actual research study that was published in a journal. And for this example, individuals who agree to genomic information are presented with lots of different ways that their information can be used in research and how their information can be shared with others. So now I'm going to talk about blockchain-based dynamic consent. So when we think about, well, what does blockchain add to this dynamic consent process? I'm showing you at left a tablet presentation that shows potential uses, future uses of research, and an individual can specify their preferences using toggle switches. That's not unusual. But when we add blockchain, we can also give opportunities for much more granular consent. Now, some of these are business decisions by the company that creates the blockchain about how they want to, what they want to offer to individuals, but it offers much more capability beyond the traditional role-based access or very prescribed methods. And when this information is added to an audit trail and it goes through and filters when there's a query, then the huge benefit and efficiency of blockchain that our customers have seen is that it can automate the access flow all the way down to the researchers. And it reduces a lot of the administrative burden that's typically associated with managing requests for data for research. So instead of an administrator having to generate a research data set and stripping the identifiers, researchers can then query and access only the data for the individuals who have given permission for that particular case and only receive the nature of information appropriate for their role. Most of the time it's de-identified or it can be a limited data set. Our life sciences customers then link the institutional review board or the review ethics board in order to release data that have undergone appropriate review. So here's an example of a publication from Kim et al., where they share how patients can have a number of different aspects of their health information. This is an example where the data are also stored on chain and can be shared with many different organizations dynamically based on patient preferences. This is an example of the granular consent features that FirstAQ offers. This is kind of a back-end solution. It's really part of our software development kit that we offer our customers. But it's just interesting to see how dynamic consent can be modified and created using blockchain. And so with these examples, we don't have the opportunity for me to click on it, but if you would click on it, you can add criteria of the conditions at which an individual is willing to share their data. It could be only to Dr. Smith or only for a certain type of research. And there's also an option for restriction that says it's fine for you to use all my research except for my research involving a certain diagnosis. and you can restrict as detailed as you like. And the consent expiration allows the consent or permissions to automatically expire at that given opportunity. So the goal is to allow much more individual control or granular manner for individuals or for the companies that are designing this, with the goal that individuals can change their minds at any time. So this screenshot shows a back-end view of what the blockchain is actually doing when an individual selects a certain consent preference. Now, this is only a brief view of the back end, but it shows some of the traditional components that we would expect in a blockchain, such as the asset ID, the timestamp, the hash. The signature is a little bit more detailed because we also have to create signature verifications that comply with FDA regulations. And the actual blockchain also stores the data on chain, most data on chain, I should say. There are some exceptions, and the owners of the data, co-owners, and all permissions that are granted. This is an example of how architecture can be designed, and this was published by Merlick et al. Last year, and just shows one strategy that organizations can use when designing a blockchain and how to create the different mechanisms to enable dynamic consent on a blockchain. Now, why would we really need this? These features seem cool, but why is it needed? So when we think about what is it that we're trying to achieve, what we're really trying to achieve with blockchain-based dynamic consent is to create an individual-oriented digital experience. So typically, we can start with some technologies such as AI and blockchain, and when we add health data and allow an individual to have dynamic consent, it opens up many more digital experiences that can be customized and personalized based on that individual's preference and to maintain an appropriate relationship with that individual. There's also lots of benefits, some of which I talked about already, about improving the efficiency of the way that the technology operates with a goal toward much more automation. And that there are some uses of health data that don't require an audit trail, but really do benefit from one. And so adding a blockchain adds a feature that some do not have. Now, with that caveat, just be aware that with primary health records and with regulated research records, those agencies have required audit trails for at least 20 years. So an audit trail isn't new when adding a blockchain, but it could be added for a system that doesn't already have one or need one based on regulatory purposes. And then there are a number of different aspects of variability, visibility, granularity, and of course, with blockchain, there's no single source of failure. When we think about some of the regulations and the advent of privacy laws, blockchain-based dynamic consent really does enable us to have more of the spirit of our ability to meet those privacy laws, including the capabilities of requests that are granular and allowing for future auditing, making withdrawal much easier, including making sure that all of an individual's choices are verifiable. And this is an example for GDPR, but I'm going to talk in greater detail about GDPR and other privacy laws when I talk about considerations and about regulatory compliance. And thus far, we've been talking about data in kind of an open way, and that for many people who are in the life sciences community, we just view data as just being these numbers. But I'd like to make an impression on you that these aren't just data. This is information about people. This is sensitive health and research data that individuals expect us to respect. And when I look into this woman's eyes, I think about how she is asking us to demonstrate respect for her health data. And this also applies to us, our parents, our children, our friends, family. And I ask you to use this as a mindset going forward whenever we talk about health blockchains or health data in general. It isn't just numbers. These are real people who ask a lot of us to be responsible and maintain their privacy and confidentiality. So now that you understand some promises of blockchain-based dynamic consent, I'm going to go through considerations and recommendations with the hope that those of you in the blockchain or healthcare community would have a better sense of how to actually operationalize blockchain-based dynamic consent so that you can do it as responsibly as possible. So the first is that we don't just maintain health data for one-time use. That's informed consent. Dynamic consent is used so that data could be used in different ways in the future and to allow individuals to change their minds. And from my experience, this is the most important component of dynamic consent when we talk about data and specimen repositories, is that we would like people to have a future say in how their information is used in the future. So as we're looking into the future, it's important to think about how we could present information to individuals so that we could honor the terms of what we say, and is our communication and behavior consistent with what individuals would likely expect? And at what point should we ask for permission again because maybe the terms have changed or the uses have changed in a way that they couldn't have expected? I also strongly encourage organizations that interact and use dynamic consent not to promise complete de-identification for data sharing, especially when giving data to researchers or maybe even selling data in permitted ways. The biggest problem is that the concept of de-identification is really becoming an illusion, and it's not hard to re-identify people using even publicly available data. So the best approach to this is just have an honest discussion about the mechanisms that you will use to try to protect and maintain their information. And I also discourage organizations from promising complete security because no system is completely secure. And so this is just a more honest conversation about the mechanisms that you will use in order to do your best and respect the individual represented with that data. A next consideration is about accessibility. And what we're talking about is digital data. And it's important to ask, well, are these technologies available to populations who may not have access to technologies or comfort with using technologies? How about access to broadband? And sufficient cognitive ability, that's not just about elderly adults, that's also about people who are very ill. And we would want to make sure that we are considering all of the populations that may be using this technology. As another consideration, consider user design on how that can affect the outcomes of the information that the permissions that you get. Now, there's so many different ways that you can present choices to individuals. And I have done research and I have designed apps in the past too. I've used combinations of buttons, checkboxes, toggle switches, and I showed an example on this screen of only toggle switches just to show you how variable that a toggle switch can be. Now, when I did my research on mobile health and I designed toggle switches, I hadn't realized how big people's fingertips can be. And it was difficult for some individuals, especially some men who work in manual labor. Their fingertips were actually too big to comfortably navigate some of the choices that I had offered. As another consideration is about color. And most of the time when we're presented with toggle switches, they are red if it's off and green if yes. But what toggle switch colors do you use for people who are colorblind? And is there an appropriate option, or should we just focus on labeling for them? And we're comfortable with red and green, but what does it mean when you have an orange toggle switch or a blue toggle switch? How should an individual interpret that so that they can accurately reflect their preferences? So also consider how those toggle switches are positioned next to the text and the labels, how accurately and how clear the labels are presented so that individuals can make choices that best reflect their preferences. When we're talking about presentation style too, it's also important to consider how you create the default settings when someone first logs in. So most of the time we are used to seeing an accept all button, and individuals are kind of I guess if they accept this, that they would accept all of the choices and all of the uses of their information without even knowing what they are. Now, when we think about, well, what's most compliant, it's important to think about some of the new privacy laws and what GDPR has been expecting. So the all yes component would not be compliant with any of the modern privacy laws. And we see this mixed option for yes, for some of the required options necessary for website functioning, but then the remaining potential uses must be selected no. And in many cases, some organizations are actually selecting all no as a presentation style because we know that patients or individuals will typically select the option, the path of least resistance. And if there are too many choices, they just say, oh, forget it. And so it's about how do we present information that's easy for people to use and communicate most ethically about what is the best approach to their information. Now, we also have to consider about individual-centered design. When we're talking about healthcare data, we talk about patient-centered design, and it's about so much more than blockchain. It's about really how do we design our technology that we can actively engage people in using the technology so that they feel like they have an active voice, an active role. And how do we get them to communicate and have that bi-directional? How do we even present information in a clear and understandable format? And as an example of that, when I did research at Denver Health, we wrote all of our communication at the 4th grade level. Why? Because not everyone has very good command over the English language, and we wanted to make sure that all information was easily understood by as many people as possible. And of course, well, we might think that certain things are really cool for the research that we want to do or the future uses of that health and research information, but it's also valuable from an individual-centered design perspective to focus on those details that those individuals care about and what would influence their decision about uses of their information so that they can make dynamic choices. This also ties into an ethical design function. And how can we use our technology to better honor those individuals' wishes and intentions, protecting their information from unauthorized use? And managing the right frequency and detail of communication is an ethical design, and it's a business decision. How often should we send them push messages to their app? How often should we try to contact them via email or to say, there's a new opportunity for you? If we wait too long, then they forget that they are participating and we don't have active engagement. So ethical values are pertinent in every industry that maintains individuals' information, but these are particularly important for technology design for healthcare and life sciences research because the information is so sensitive. And if you'd like to learn more about blockchain ethical design, these are some great resources that are available free on the internet. And I was an active contributor to this GBA document about Government Blockchain Association document about blockchain ethical design framework for healthcare. Instead of focusing only on the flashy features or some of the user interface, I also encourage you to think about the entire software development lifecycle for the technology. And I regularly ask my peers in the blockchain community, well, what does the end look like? And healthcare customers are required to plan for the end of any technology. And these are all concepts that we at Burst IQ actually build into the contracts with our customers, including sometimes the requirement of putting all of our blockchain code into escrow if there is a potential problem. So here are the realistic situations that we should plan for, such as data being transferred to a different platform, maybe the project no longer be needed because the longer the data are maintained, the more that they could be at risk. How about after a major data breach? And remember, healthcare data are targeted more than any other type of data on the internet and carry more value. So if there is a breach involving health information, can we pause the activity? Can we remove it from a chain temporarily? These are all questions to consider, as well as what happens when the vendor, how about the healthcare organization gets sold or goes out of business? And someday the technology that we're using today will become obsolete. And my friends in the quantum computing environment love to remind me of the upcoming risk to blockchain. So while you don't have to necessarily have a clear response for each of these are valuable to consider because healthcare organizations will be asking you these questions. We've talked a bit about security in other presentations, but I like to remind everyone, blockchain is software, not magic. It's designed by humans, programmed by humans, administered by humans, and operated by humans. And we really should not overstate the security of any technology. Of course, blockchain isn't perfect or completely impervious to threats, but we can use current good manufacturing practices to design and document the code development, training, and testing to greatly increase the security of any technology. So now I'm going to talk about applicable regulations that organizations should consider when designing any technology, but also I'm going to focus on blockchain for pertaining to healthcare privacy research, breach, and the due diligence documentation. So I specialize in life sciences implementations of blockchain, and we start first and foremost with reviewing the regulatory requirements. Now, with any regulated data, you have to know what the regulations require. And so this is where we document the scope of what we're trying to do, the security requirements, such as access methods, controls, backups, archiving error messages. I'll go into those in a bit more detail. What will be audited? Policies and procedures and training records. Those are all required for the regulated data in healthcare and life sciences. They could have variations by country. So starting out with some of the regulations that have to be designed into the platform itself. Many companies that design blockchains focus on the function, but they don't realize what the back end must also include per the regulations. And it would be difficult, if not impossible, to retrofit. This is in this area, I thought it would be helpful to share one of my own experiences. And that the blockchain that I work with, BurstIQ, was designed from the ground up to be compliant with healthcare regulations in the United States. And it has worked wonderfully for the healthcare regulations. But after we did a project with the US National Institutes of Health, the NIH asked us to get FedRAMP authorized. And for those of you not familiar with FedRAMP, it's an acronym for the Federal Risk and Authorization Management Program that requires very high levels of system security for any data managed by the federal government. And these are examples of the requirements in the FedRAMP authorization checklist that our technology couldn't meet in its current state. And we are actually in the process of rebuilding our platform. We're starting with a second platform that will have all of these components designed into the different layers of the technology so we can meet these requirements. The most important consideration to take away for you is just to be aware of what the requirements could be so that you don't have to go back and potentially retrofit or rebuild an enormous platform. For healthcare, sorry, my mouse. For healthcare, the health data regulations have many different aspects, and some of these may need to be centralized. So around the world, many health data requirements involve having an administrator from the healthcare organization manage the access and granting access individually, and verifying the identity of individuals who are granted access. There are also some other components that are generally centralized, such as the nature of scanning, validation, and intrusion detection. It doesn't matter which layer of the architecture stack it takes place in, but it's really important to understand, well, what would be required if we wanted to use our technology for healthcare? What would we have to design in the build somewhere? Now, I talked about privacy a little earlier, and we're all familiar with the requirements of GDPR. Of course, Canada has many privacy laws that differ by state. And for those of you who do business with the United States, it's valuable to know that there is now a patchwork of privacy laws, and each state has its own nuances for what they consider important to be part of their privacy legislation. I'm bringing up this slide because it's valuable to know that nearly all of these regulations or state statutes specify deletion. And some people in the blockchain community say, oh, well, you can't delete from a blockchain, or you can't delete from any blockchain-based information. So of particular note, I serve on, let me back up. Blockchain can allow you, and we design layers of governance so that you can build in smart contracts that help you comply with some of the different jurisdictional requirements. Also, for health and research records, there are exceptions about deletion, because we definitely need continuity of care and integrity with our research records. For web-based programs, for apps, there is a requirement to delete the information upon request. There are some circumstances. And so it's valuable to know that there are currently 6 published methods for addressing blockchain-based data deletion. We at BurstIQ have been deleting data based on different mechanisms. And it just does depend on which platform or protocol is used. What are the regulatory requirements? And like, do you need to maintain an audit trail for a certain period of time, and your own business policies and practices? Now, it's valuable to note, Vicki mentioned earlier that I serve on the European Union Blockchain Observatory and Forum, which advises the European Commission about blockchain applications across many industries. And we recently created a report, the blockchain applications in the healthcare sector, and we actually got to work very closely with commission members in order to create content that appealed to their interests, and their goal to make the European Union a commercially viable and attractive sector for blockchain. And I knew that this concept of the right to be forgotten would come up. And when we had the conversations with the commission members, it was really a non-issue, because there had been so many different established methods about how actual health blockchains have been addressing this. And so the final conclusion is that blockchains are not incompatible with GDPR or other privacy laws, but you just have to be very mindful of how the system is designed. So next, it's valuable to consider regulatory audit trails. And this is an example of a real audit trail that I found on the internet of a company saying, oh, yes, you should use our blockchain for your health data, because we can track all the information that would be of interest to you. And you can see individuals are represented with their public keys, and the activities are noted with hashes. And I have a friend who has been really excited that his blockchain company is designing dynamic consent for the pharmaceutical industry in the United States. And I said, that's fantastic. How are you meeting the requirements for Part 11? And he said, what's that? And I said, what, 21 CFR Part 11? It's the regulatory requirement that all regulated data must follow. And he didn't even know. And so I shared that conversation with some FDA officials, and not naming him, of course. And they laughed out loud, and they said, this is one of the biggest complaints that they have with the development of blockchain in a number of healthcare and life sciences industries, is that there are some really passionate developers who really haven't done their homework about what they need to design into an audit trail, into the technology itself. And so just to create better awareness, an FDA compliant audit trail looks like this. And it has to contain the name or username for each individual, and it has to be name, not hash. Hash does not work at all. As well as type of event, type of date stamp, the original value, and the value that it was changed to. And the presentation must be in both machine readable and human readable format. And the FDA officials I spoke with said that the hashes that many organizations use for their blockchain-based audit trails are not acceptable because they are not human readable. So these capabilities can be designed to in any of the layers. Some organizations just use an existing compliant software technology and then attach a blockchain underneath. Just be aware of the different components that may be required. Also, there is another area for lesser regulated data, and that's the laws pertaining to breach notifications. So when we're designing web apps or healthcare non-regulated health or life sciences data, they still can be subject to brief notification laws. And both the US and Canada have federal and state level requirements for reporting breaches of health data from consumer devices. And so it's just important to plan and ask yourself, what would you do if you had a breach? So after you've gone through all these regulatory determinations, it's important to document how you've met them. And while I wrote ACME as being the organization in these documents, these are based on real documents that I wrote. And this was my due diligence document for a pharmacovigilance global safety database. And this is taken from the due diligence I wrote for the Burst IQ blockchain for the work that we do to meet 21 CFR Part 11 and Annex 11 for the EMA. And it's if I didn't have this documentation, it would be a deal breaker for the life sciences companies that we talk to, because they can't hire any vendor unless the vendor can produce this level of due diligence. And so all of this documentation should be assembled. And for life sciences organizations, there is a higher standard for the nature of development, verification, validation. And we also have to produce swim lanes and architecture diagrams to meet the requirements for an audit. So after organizations have gone through this and they have these great ideas, I always ask, well, do you really need to build a blockchain to do what you're seeking for dynamic consent, or are there any commercial off-the-shelf solutions? Blockchain can add additional features, but not everyone needs those. And so it's just valuable to consider, well, what is already available so that we can make sure that we are best spending our energy. So as some final thoughts, this conference has talked extensively about trust. And I love what Wen stated earlier about trust. And when we think about what trust is and what it's not, we have to think about how maintaining trust is a tremendous responsibility. And trust is only as strong as the weakest link. Now, I am beseeching you that trust isn't a component just because we use blockchains for healthcare. People trust us because of the way that we behave. And this is where we can implement trusted organizations, where we can build bonds with our customers and attract great talent and create engagement models such as dynamic consent, all while minimizing risk. So I hope that as some takeaways from this presentation today, that you remember that dynamic consent in health does demonstrate more respect, that blockchain can automate some of these features, and that it's important to review all the appropriate business and regulatory considerations so that we can create a foundation of trust. And I'll leave you with a quote. We are challenged to create a future in which data are connected, individual privacy and ownership rights are respected, incentives are aligned, and trust is inherent. And so I am eager for your questions, especially starting with students. And please reach out to me if you have any additional questions or thoughts. And also, I offer free Health Blockchain 101 presentations for any organization that asks, because my goal is just to elevate the level of knowledge and discussion in this area. So thank you very much, and I'll turn it back over to Vicki.
I'm muted. Thank you, Wendy. That was fantastic. And it really brings home, very, very real world use case and the implications of all of the decisions we make, all of the, abstract technologies and theories that we might have, bringing it home to very real world use cases. So we did go up to the top of the hour,
Okay.
but I don't want to leave this without opening up for a few questions. And
Great.
we are all students here, so we will
Yes.
take questions regardless of whether they came from
Okay.
students or not. I'm a student in your presence for sure. And so we have a couple of questions that have been posed already, and we'll address those. And for those of you who would like to ask some more questions of Wendy when we move into our next session, then perhaps you can post to the chat and she would be gracious enough to respond on the chat. So one starting from Andrew asks, I'm curious about how you can keep the blockchain nodes from misusing data, like keeping a copy of it and using it without leaving a trace on the audit log. It seems like someone is in possession of the data. It's hard to keep them honest. So what do you think?
Yeah, he's got a point from a technical standpoint, and where it's typically managed for health and life sciences consortia is through a detailed consortium agreement and through legal contracts. When we have worked with health related consortia, it's actually taken about a year to negotiate all of the terms through everyone's attorneys. And then behavior can be better tracked on some blockchain capabilities. For life sciences data, each node would also have to be compliant with that regulation for data management. So there can often be an audit trail. The biggest obstacle that we all face in research, regardless of whether or not we're using blockchain, is that once the data are downloaded, there's no technology that can control what happens to it after that.
Yeah, absolutely. I know we've got a presentation coming up that starts to address that issue for sure. So Matthew's asking, how do patients control the blockchain? How do patients control the blockchain described? Do they own their own private keys that provide authorization, signing, and encryption? And if they do not own those keys, do you see this as something that is being considered in the future?
Okay, great question. So first and foremost, patients don't know that they're interacting with blockchain. And it's designed as a back-end solution. What we have done is interact with single sign-on with healthcare organizations so that if a patient signs into a patient portal, then they also have access to the blockchain-based components. A second feature that we frequently do is we create a hidden hot wallet, where the public and private keys are hidden in the technology and an individual logs in with a username and password. And because we can't risk the possibility that if someone loses their keys, they lose access to their health information, we have capabilities where people can reset their password or contact an administrator so that an administrator can resend a link for someone to reset their passwords. So it may not be quite as secure as the public and private keys, but we have to face the reality that of who the users are, and that it's hard enough for people to manage a username and password, much less keys. So this is the mechanism that our customers have chosen to overcome some of those usage obstacles.
Right. And then maybe just a quick final question from me. You talked about, the dynamic consent, and I wondered, how is compliance with the dynamic consent settings provable? Is it through the audit trails, or is it through, actual human audits, or is it through cryptography? How are you achieving that?
Yeah, so I can only speak knowledgeably about the projects that I am involved in. So Burst IQ stores data on chain, and we actually design mechanisms for researchers to gain access to like a data repository, and then all of their activities are tracked on the blockchain. We actually require them to log in and connect their statistical software to the platform, and they do their analyses in read-only format instead of allowing them to download Of course, we're all aware that sophisticated users could find ways of saving it, but at least it maintains a single source. And then there are separate dashboards for compliance officials and quality assurance officials. There really has to be an administrator for a data repository involving dynamic consent, because we have to verify through regulation that the data are protected and the access has been controlled and only accessed by authorized users.
Yeah, great. Wendy, I regret that it's
I'm sorry, yeah, that
us
I
to
went
go to
long.
our next presentations, but
Okay.
thank you again. I'll just ask you to stop sharing, and I will queue up our next presentation. But thank you again for a really stimulating conversation. And please do respond to any other questions in the chat if you're able to.